Welcome to this explainer. Today, we're diving into something I like to call the awakening giant, the incredibly rapid collision between AI, data centers, and our physical power grid. We're looking at a truly surprising transformation in a sector most people, honestly, rarely even think about. It's the story of how our invisible digital world is violently clashing with our physical, real-world infrastructure.
For the longest time, the utility sector, the folks managing our power grids and generating our electricity, was considered a pretty slow, sleepy, and frankly somewhat stagnant industry. Think about this. For over a decade, stretching from 2005 all the way to 2021, electricity demand across the US, Europe, and North America was completely flat. Literally 0% growth. Sure, we were building more houses, plugging in way more gadgets, but massive efficiency gains in our appliances, mixed with some deindustrialization, perfectly balanced out any new consumption. For utility planners, the future looked entirely, boringly predictable. The era of flat power demand felt permanent.
And then, bam, everything flips. In just the past 3 years, the 5-year forecast for peak power demand hasn't just grown, it has absolutely skyrocketed. We are talking about a 6-fold increase. It jumped from a totally manageable forecast of 24 gigawatts of new peak load up to a staggering 166 gigawatts. To put that into perspective, electricity usage is now forecast to grow by an average of 5.7% every single year over the next 5 years. So much for predictable, right? The quiet days of utility management are officially over.
So you gotta ask yourself, how on earth does a sector that barely moved an inch for 15 years suddenly find itself staring down the barrel of a 166 gigawatt jump in demand? What is out there that's so massive, so incredibly power-hungry, that it requires the electricity industry to plan and build new generation capacity at more than 6 times the rate we've seen recently? Okay, let's dive into this breakdown. Where is that massive forecast actually coming from? Well, industrial manufacturing, oil and gas, and general building electrification are for sure contributing to the surge. But look at that massive 55% chunk. That is entirely data centers. They alone are demanding roughly 90 gigawatts of this newly forecasted power over the next 5 years. Artificial intelligence, cloud computing, advanced manufacturing, these are the undeniable new drivers of our electricity grid. And data centers, they are the absolute heavyweights here. But here's where it gets kind of chaotic. Nobody can perfectly agree on the exact numbers. While the utilities themselves are forecasting that 90 gigawatts of data center demand, independent market analysts are predicting the number will likely be closer to 65 gigawatts by 2030. So that implies the utility forecast might be collectively overstating data center growth by, about 40%. Why the huge discrepancy? Honestly, it all comes down to the sheer uncertainty of project completion, supply chain constraints, and just a general industry-wide scramble to understand the unprecedented velocity of this digital explosion.
Let's step back from the abstract spreadsheets and forecasts for a second. We tend to think of AI and digital data as this invisible thing, right? Just floating out in the cloud. But the cloud has a physical reality. Every single ChatGPT prompt, every movie we stream, every complex algorithm, it all lives in massive, physical aisles of endless server racks. And those servers generate intense heat, which requires immense amounts of continuous electricity and huge cooling systems just to process our day-to-day digital lives.
And this physical footprint, it is expanding exponentially. Historically, a typical data center campus required about 40 megawatts of power. Today, those standard campuses are routinely scaling to over 100 megawatts. But here's the mind-bending part. Almost 50% of new data centers planned for 2030 or sooner are being designed to draw more than 1,000 megawatts. Because of this massive scale, traditional primary tech hubs, places like Silicon Valley and Northern Virginia, are physically tapped out. Their power availability is totally constrained. So developers are aggressively hunting for scarce power, pushing far out into completely new secondary markets that have never even seen a data center before.
And this physical strain isn't spread evenly. It is highly concentrated. Just 6 regional grid territories represent over 80% of the projected 5-year growth in the US. Grid operators like ERCOT in Texas, PJM covering the Mid-Atlantic up through Ohio, and SPP in the central US, they are bearing the absolute brunt of the AI revolution. And they are having to move incredibly fast to prepare for operational challenges they've never faced before. To really grasp those operational challenges, we need to understand a vital industry concept called load factor. Simply put, load factor is the ratio of average energy use to peak load. It doesn't just tell us how much power a customer needs, it tells us how constantly they need it. If you have a high load factor, it means you're drawing maximum power almost all the time. Day, night, weekend, holiday, it doesn't matter. You never rest.
And here is the glaring mismatch that is literally keeping grid operators awake at night. The current U.S. power grid operates at about a 60% load factor. We naturally use more power during the day and less at night. It ebbs and flows. But these new data centers, they operate at a relentless 82 to 96% load factor. They are these massive, high-energy customers that turn on and essentially never turn off. That kind of high-energy character fundamentally breaks the way planners expect the grid to behave.
Now, what's really interesting about this next point is the sheer volatility that AI introduces on top of all that constant demand. Because it's not just a steady hum of servers anymore. AI data centers run these massive training models that process huge batches of data and then abruptly stop. Grid observers have literally watched a 450 megawatt data center drop to just 7 megawatts of demand in 36 seconds. 36 seconds! Just imagine the power draw of an entire medium-sized city vanishing from the power grid in less than a minute. You can imagine the absolute chaos that causes for the grid. And it's not just AI training models causing these rapid fluctuations. Sensitive computer equipment can trigger what the industry calls voltage ride-throughs, where massive backup power systems instantly activate because of a minor grid fault, like a lightning strike miles away. Add in crypto mining operations, which can scale their load up or down by almost 100% instantly just based on Bitcoin prices. And you've got a grid that requires massive, instantaneous responses from utilities just to keep the lights on for the rest of us. Now let's zoom out for a quick second. While AI and data centers are absolutely driving the demand spike here in the US, it's vital to look at the global picture. Grids all over the world are being stressed simultaneously, just for different reasons. Over in developing economies like India and Southeast Asia, rising global temperatures are turning space cooling, like air conditioning, into a massive new demand driver. Meanwhile, Africa is working to expand electricity access to over 500 million people to drive industrialization. The hunger for power is a truly global phenomenon right now.
So, how on earth does the world solve this? Well, with capital, mountains of it. The financial resolution to this looming crisis is frankly monumental. Back in 2015, global energy investment sat at roughly $2.6 trillion, but by 2026, that number is expected to leap to $3.4 trillion. The global economy is mobilizing trillions upon trillions of dollars to reinforce grids, secure energy sources, and adapt to this crazy high-demand future. And this brilliantly illustrates exactly where that capital is flowing over this decade of transformation. Investment is pouring heavily into renewables, expanding power grids, and broad electrification. Coming off the energy shocks of the past few years, countries aren't just scrambling to power AI, they are prioritizing low-emissions power and strict energy security to ensure their entire infrastructure doesn't just collapse under the weight of the future. Which brings us to the ultimate million-dollar question to leave you with today. As our digital ambitions continue to grow at an exponential rate, can our physical infrastructure actually survive the surge? We've traded a decade of sleepy stagnation for an era of hypergrowth driven by the cloud, AI, and global modernization. The data centers are definitely being built, the trillions are being invested, but the ultimate test will be whether the physical wires, the transformers, and the power plants can actually keep up with our relentless digital appetite. Thanks so much for joining me on this explainer, and I'll see you next time.